Okay, so today what we're going to do is we're going to talk a little bit about relations and the coordinate system. We're just going to kind of get into it. There's a lot of information in this one video, a lot of definitions, so pay attention and make sure that you get this information. All right, so first thing is the coordinate system. You've heard it called a coordinate grid, a coordinate graph. There's lots of different things that they call this. I normally call it the coordinate plane or the coordinate grid, one of the two. But different teachers are going to call it different things. You need to know all of them so that when they say it, you understand what they're talking about. And really what they're talking about is this right here. Okay? Now, it's formed by intersections of two number lines. Number lines, you've seen number lines well now. You got the horizontal axis and the vertical axis. The horizontal axis is your x-axis right here. This is where you go, if they give you an x, you go left and right along the one. That's the number line that most of us deal with on a normal daily basis. Okay? But then you also got your vertical axis. This is your y-axis. This is basically going up and down. Okay? So at the center of that, you have the origin. That is where the x-axis and the y-axis intersect. That's the very center right here. Okay? That's ordered pair is 0, 0. Okay? Is the point where the axes intersect. So make sure that you know that point. Make sure you know that this x, this horizontal line, that's the x-axis. Make sure that you know that this vertical line is the y-axis. Those are very important things to know as we move forward. Okay? Now, what you can do is you can take an ordered pair and put them onto this grid. It's basically what it's for. A point is represented on a graph using ordered pairs. So you go in here and you find a point like this, 2, 3, that's an ordered pair. The first number is your x, the second number is your y. So what you do first when you go to graph this point, go over 2, 1, 2, and then up 3. 1, 2, 3. You do the x first, then the y, and it's always represented with parentheses around it and a comma in between the two numbers. So whenever you list an ordered pair or you show an ordered pair, that's how you're doing that. Okay? You've seen this before. It's just a quick review of it. So let's move from there. Very important that you know how to graph on the coordinate grid, though. Very important. Okay? An ordered pair is a set of numbers or coordinates written in the form of x, comma, y. Again, the x, that first number, is how you go left or right on the coordinate plane, and the y, the second number, is how you go up or down on the coordinate plane. Very important to know that. The x value, called the x-coordinate, represents the horizontal placement of the point. That's what I just talked about. The y value, or the y-coordinate, represents the vertical placement of the point, right? So the x-coordinate tells you left or right. The y-coordinate tells you up or down. Okay? A set of ordered pairs is called a relation. Now this is kind of important. A set of ordered pairs. So when you have a list of ordered pairs, it's a relation. A relation can be represented in several different ways as an equation in a graph with a table or with mapping. Okay, so we're going to go through all these different ways that you can see how to list a relation. We're going to start with mapping. This is mapping right here. That's what this is. Okay? A mapping illustrates how each element of the domain is paired with an element in the range. Okay? Well, wait. A mapping illustrates how each element of the domain is paired with an element in the range. Well, guys, the domain is your x. The range is your y. The x and y have multiple names as you go forward, right? They have the domain, the range. They also have a couple over here. So here's all the list of different ways that they're going to list out what the x is. You got domain, input, independent. Y's are range, output, dependent. And they will switch between these depending on what they're talking about. So you need to know these and know what they represent, right? So x, domain, input, and independent are all the same thing. The y, the range, the output, dependent, all the same thing. And I know I just said that twice, but it's that important that you need to know it, because they're going to use them differently. Okay? So the second set of numbers of the ordered pair is the range. The first number of ordered pairs is the domain. So if they give you this, mapping represents the ordered pairs. So if they give you this list of ordered pairs right here, that's what that is, a relation. This is a list of ordered pairs or a relation. Then you can be able to come in here, you can put them on a mapping sequence, or you could come up here and you could put them on the coordinate plane. There's different ways that you could represent this. Right? So here are all the different ways that they can represent this. You can just list out the ordered pairs. That works. You can write it in a t-chart or t-table. That works. Notice this is the x, this is your y, this is your domain, this is your range, input, output, independent, dependent. Okay? Works that way. You can put it on the graph, and you can put it in a mapping. You need to be proficient with every one of these methods. You're going to see them differently at different times. And what they may do is give you one and say, give me the other three. They may give you the other three and ask for the one that's missing. You don't know. So you need to know about them all. You've seen them all. Just make sure you can use them. Okay? All right, so here's an example of what they might do, right? Here, express this relation as a table, a graph, and mapping. Well, here's your t-chart, right? Table. Place the x coordinates into the first column of the table. Place the corresponding y coordinates in the second column of the table. Well, notice 2 and 5, 2 and 5. That's your first order pair. So when you're looking at a t-chart or a t-table, the x and the y right next to each other, that's an ordered pair. Very important to know that. A lot of people mess that up. Here's your x, here's your y. Together, those two things are an ordered pair. Here's an x, here's a y. I know those two things are an ordered pair. Look, 2, 5, negative 2, 3. 2, 5, negative 2, 3. The next is 5, negative 2. Again, that's an ordered pair. That's how you know what your ordered pairs are as you come through here. Negative 1, negative 2. Negative 1, negative 2. That's an ordered pair. All right. Then we come down here to a graph. Again, just come over, go up, over 2, up 5. That's a point on the graph. That's an ordered pair. That's a coordinate on your plane. And they do it the same for all of these. Now normally you should label them. Should be something like this, 2, 5 out beside it, so that you can see exactly what it is. They didn't do that, but they should have. And then over here, your mapping sequence. List the x values in the domain and the y value in the range. Draw arrows from the x values in the domain to the corresponding y values in the range. This is called mapping. 2, 5, there's the arrow. Negative 2, 3, there's the arrow. Those are ordered pairs. The 2 and the 5, the negative 2 and the 3, 5, negative 2. Oh, that's an ordered pair. Negative 1, negative 2, that's an ordered pair. Okay. Determine the domain and the range of the relationship, or relation. Determine the domain and range of the relation. Well, all of the x's are the domain. All of the y's are the range. So the domain of the relation would be all of these. 2, negative 2, 5, and negative 1. 2, negative 2, 5, negative 1. All of the range is going to be right here. Now notice, there's 4 domains and 3 ranges. That's okay. Right? The range of the relation is 5, 3, and negative 2. It's okay. You've got 2 ordered pairs with the same y. That's going to happen on occasion. Just pay attention to what they're giving you. If I came down here, express 4, negative 3, 3, 2, express this relation as a table, graph, and mapping. So you'd go in there and you'd set it up as a graph, as a t-chart, as a mapping. The 4, the 3, the negative 4, the 0, determine the domain and range. Those are all your domain. The 4, the 3, negative 4, 0, all domain. And your range, negative 3, 2, 1, negative 3, all your range. Remember, domain is your x's, range is your y's. The x is always first, the y is always second. Very important. I see a lot of kids mix that up. Don't do that. Right? In a relation, the value of the variables that determines the output is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. So the dependent variable depends on the independent. That's all that's saying. The independent, it can stand alone. Okay? That's what you're looking at. So, again, independent is your x, dependent is your y, and here they give you some real world examples. Okay? These are really what you're going to be looking at. Okay? Don't do that. Okay? Identify the independent and dependent variables for each relation. Well, the dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. Okay, so which one affects the other? That's what you're looking at here. Well, the more tickets that they sell, the greater the amount of money they can spend for decorations. So the number of tickets that they sell stands alone. It's independent. The amount of money they can spend is dependent on how much they sell. So independent is the tickets they sell, dependent is the amount of money they can spend on decorations. Pay attention to the way that works. That's what you're looking for. Okay? Generally, the average of price going to the movies has steadily increased over time. Okay, time is one of those special cases. It's always your x. It's always your independent. Okay? It's always your input, your domain. It's always that one. Okay? So time is independent variable because it is unaffected by the cost of attending the movies. The cost of the movies is your dependent because it does get affected by time. That's what you're looking at in that scenario. Just remember that time going to be your independent. Right. So the air pressure inside a tire increases with the temperature. Temperature stands alone. Air pressure increases as the temperature. The air pressure inside the tire increases with the temperature. Yeah. So temperature, independent. Air pressure, dependent on the temperature. Okay? As the amount of rain decreases, so does the water level of the river. Well, as the amount of rain decreases, so this happens, and then this happens. Independent, dependent. That's what you're looking for. Don't overcomplicate it. Look which one is affected by the other. That's what you're looking for. All right. The graph represents the distance Francesca has ridden on her bike. Describe what happens in the graph. So you have to be able to read graphs and kind of determine what happens. So if you look at this, time, again, always your x. Here your distance is your y. So what happens is she starts riding. Well, she goes a distance. But then right here, it flatlines. It doesn't change. It probably means she stopped. So from here to here, she stopped and then she started riding again. So she started going a distance. So you got to be able to look at this and determine what's going on, right? As time increases, the distance increases until the graph becomes a horizontal line, right? From here to here, and then it goes horizontal. So time is increasing, but the distance remains constant. At this section, Francesca stopped. Then she continued to ride her bike. Got to be able to read that, understand what's going on. Describe what is happening in each graph. Driving to school. So they're driving to school. So they start off, they go a long distance in a short amount of time. Probably going at a pretty fast speed, might be on a highway, might be something like that. Then they come to a stop because they go horizontal. Then start again, hit another stop sign, go start again, and now they're there. Pay attention to kind of what's going on in the graphs. Okay? Let's see here. Yeah. If you can do those things, you're going to be pretty good. Again, watch, know the information on what a system is, ordered pairs, y-axis, x-axis, ordered pairs, which one is the x, which one is the y, And then make sure that you know that X domain, input independent, Y range, output and dependent, know those. Make sure you know what's representing what. And you should be good. If you have any questions, let me know.